Okay, guys, hi. Today we're going to be talking about different things that affect force. So, what is it that affects force? So, for instance, if something is being pulled, what's going to affect that pull or what's going to affect that push? And so, we're going to talk about what affects the different types of forces that act upon an object. If you guys look here, we're going to actually be working on a website. So I'm going to pull up a website here in a second, and it's got a demonstration to show you some different things happening when a force is applied to an object. Okay, so I'm going to go ahead and pull up the internet here. That's not it. There we go. Okay, so what we're going to do is we're going to look at a concept called friction, and so we're starting off with thinking about, have you ever skated over ice? I know we got some hockey players out there. Do you think that you can skate the same way over a concrete road? Well, of course not, obviously, because the friction, which is a force, it stops your skates from, or it's a type of thing that affects force. It stops your skates from sliding over the concrete road. Okay, so we're going to look at some friction. Okay, right now what I've got here is I've got a ramp, and we're going to be able to select different types of surfaces for our ramp. And what I've got here is a wooden block, and I've got this section here where it's basically creating a push. Okay, and so it's going to push the wooden block across the different types of surfaces, and we're going to be able to see the distance in which this object will travel on the surface. Okay, so let's start off with a metal surface. So before we start, I want you to think about, how far do you think the block will travel? Will it travel here to the end, to the middle, or not go very far at all? Okay, so make that prediction in your mind, and now let's take a look. Okay, so it exerts a certain amount of force on it, and that block almost made it here to the end. The reason why is because the metal, it's very smooth and a hard surface. There's very little friction. We're going to talk more about friction here in a second. It's basically something that it's on the surface that affects the movement of an object. So like this wooden box, it's going to really slide really easily along the ramp. Okay, now let's look at another surface. This time we have wood, a wooden surface. So now we have wooden surface and we have a wooden block. Let's see how far it will go. Do you think it's going to go all the way to the end, to the middle, or to not go very far? So make your prediction before I press go. And let's see. Okay, so it's not quite as far as the metal surface, but still it went pretty far. Wood actually has a fairly rough surface if it hasn't been sanded, so it does create some friction. And since the wooden block itself has a rougher surface, when you have a rough surface rubbing up against a rougher surface again, it's going to create more friction. So that block didn't move as far. Okay, and it basically was a force that stopped the object from being pushed as far. Okay, all right, let's look at our last surface that we have, and that is sandpaper. Okay, if you've ever felt sandpaper before, it just feels like grains of sand that have been glued onto a piece of paper. And so it's a very rough surface. So now we've got sandpaper as our surface, we've got our wooden block here, and I want you to think about, when I apply the same push force, how far is this block going to move? Is it going to go all the way to the end? Is it going to go somewhere here in the middle, kind of like the wooden surface did? Or is it going to stick closer here to my push force if it doesn't go very far? Okay, so make your prediction, and now let's go ahead and see it move. Okay, you can see that since it has a really rough surface, it creates a lot of friction, and so that's going to keep that wooden block from sliding very far. Okay? All right, so now what we're going to do is, we've looked at that. Now we've completed the explore activity. I want you guys to think about what caused that wooden block to move different distances. So first of all, ask yourself, was the force the same for each push? Well, yeah, it was, because I used the same gadget, I applied the same amount of force each time. Did I have the same block each time? Yep, I did, because that block never changed size or shape or anything like that. And the motion, we did have a motion each time, so I know that work was being done, because, right, I know that I have to have a force, an object, and a motion. My force was the push, my motion was the movement. So we know work was being done, but what affected the amount of force I was able to use? Well, it was the distance, or I'm sorry, it was the type of surface that I used. Okay, and so the surface on which I'm moving something is going to cause my object to not move as far. Okay? Now the next thing we're going to do is we've got a short little video that I'm going to show you about friction.
While gravity keeps these cars racing on the track, another force, friction, also plays a big role. At the starting line, the goal is to increase the friction between the tires and the road. More friction means greater grip or traction. Drag racers work at increasing the frictional force between the tires and the road. Before the race, the tires are hosed down. Then the drivers spin their wheels. The tires become warm and actually stick to the road. Because the tires don't have tread, they stick just the right amount, giving them grip at the start of the race. Friction is at work for ordinary drivers too. When a driver puts on the brakes, friction causes the car to stop. Many factors determine the degree of friction between tires and the road. In general, the greater the tread on the tires, the more friction there is, and the easier it is to stop. The conditions of the road also affect friction. The drier the road, the greater the friction between the tires and the road, and the easier it is to stop. There is less friction between the tires and a wet road, making it harder to stop. Did you ever notice how hard it is to move a heavy object, but once you get it going, it seems to move more easily? That's friction again. Static friction keeps this box from moving and keeps this object at the top of the ramp. Once the block starts moving, kinetic friction slows it down so that it comes to a stop. Athletes have thought of ways to reduce friction so that they can enjoy a faster ride. Downhill skiers rely on the smooth base of their skis to increase their speed. In the air, friction is created when an airplane moves through our dense atmosphere. To overcome this, engineers streamline the designs of planes to minimize air resistance. Movement is part of our world. We can measure distance, speed, and direction. We also understand how forces such as gravity and friction affect how fast people and vehicles can travel. As we go about our daily lives, these forces are at work. Now that you've seen facts about forces, talk about this. What is the difference between kinetic friction and static friction?
Okay, so now we finished up with the video, and after we finished up, whoops, went too far. After we finished up with the video, now you guys have your questions that you'll be answering. So go on over to My Big Campus and finish up answering the questions all about friction. Okay? Have a good one. We'll see you guys. Whoops. Sorry.